Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is a discussion around the question that comes up very often, and that is estimation variability. Why are our estimates so variable? In particular, and so inexact. In particular for agile teams. This is the context where I'm mostly discussing this. But some of these things apply in general. So before we move on, I have to say that there are some things that are general about this problem and some things that are very specific to the organizations. So you might not get full answers. In order to get full answers, I invite you to attend one of our learning programs or contact us for a specific learning session. But basically, we will go through the general ones, the one that apply to most organizations. Not to all of them, but to most. The complaint typically goes as such. The teams are doing an estimation, and the estimation is sometimes inside the sprint, what fits inside the sprint, but more often than that, it's about things that span over multiple sprints, because we need a specific feature by a specific date, for example, or we promised a specific feature or something like that. So I will just attack the core of the issue and just talk about the estimation, but please know that there are more complex things regarding the ecosystem in which this happens. So for example, you could remove the need for estimation by just prioritizing instead of promising specific dates. And you could be, if you're doing product management in a good way, you could actually consider the product and the growth of the product instead of promising specific features. So there are some things here which we can discuss in more detail, but that would take too long and it's kind of outside the scope of this. So let me just focus in estimation per se, ignore everything else, and talk about estimation variability. So first of all, we have to understand that variability is built into an estimation. That's true for every estimation. That's actually true for every measure. One of the first things I've learned in engineering in University of Polytechnics, where I did my university studies, is that every measurement has an associated error rate. And because no tool is perfect for measuring, so you will always have 1%, 5%, then you can see this in tolerances for various tools that measure things. And this is true for physical stuff, for stuff that you can see, you can touch, you can measure with quite some accuracy. But what about stuff that we imagine? Why do we expect the stuff that we imagine will be better and with less variability than stuff that we can physically measure? It doesn't make any sense. So actually, variability of estimation is something that's built into the word estimation. It's not something that you can avoid. Now, there is a trick here that we can deal with, particularly when we are doing a lot of things. There are actually two things that you can use to your advantage. One of them is that errors might cancel if you're doing a large enough number of items. What I mean by that is if you have 100 tasks, it's likely then, let's say 30 will skew 5% or 10% in one direction, 30 of them will skew 30% in the other direction, or 10%, and they kind of get the estimation gets the error of estimation gets cancelled over a long enough period. Now, if you are doing this in Agile, in Scrum, in other organization method, but mostly we are talking about Scrum here, what this means is you will get over a longer period of time, you should get better predictions than over short periods of time. Even if one sprint is not going that well, it might happen that over 10 sprints, things are on track, or at least as you expect. The other thing that you can use is work with very small tasks. So if you master incremental thinking, which means splitting a big problem into smaller problems, prioritizing them based on value, what is the most important problem to solve first from that big problem, and then going maybe again split into even smaller problems, what is the most important ones to solve for this one, and then you go into very small changes or incremental an incremental way of working, then you can quickly adjust and you can create maximum of the value with minimal effort. Not completely true, okay, because you cannot optimize 100%, but you can get better at this. So if you are using smaller pieces, it's easier to estimate. The error will tend to be lower, and over the a longer period, you'll get better results. Now, so variability is built in, but let's talk about sources of variability, because this is where it's important. We can roughly talk about two types of sources. One is essential variability, a type of variability that you cannot avoid because it just happens, right? It's part of the nature. And the second one is accidental, things that happen that you can work upon. Although some of them are, if you are in a team, some of them are under your team's control, others are outside of your control. So you have to be careful with that. And we're going to talk about this. So the most important essential aspect of variability in estimation is that we've never done this before. So imagine you are starting a new task or a new feature that uses a completely new technology, maybe a new programming language that you haven't used before. Maybe the problem is something that you haven't solved before. You've only done, I don't know, web applications, and now you need to do an algorithm to optimize financial transactions. How long do you think it will take you? Well, you have no idea, right? It might take you for 1 week to 6 months, because it's so the lack of knowledge makes this so imprecise. It's impossible to figure out the correct estimate for this. Now, if we make this slightly easier, so let's say you know the programming language, you know the technology, let's say you're using Java and Spring Boot, but now you need to implement something using webhooks and you've never used webhooks before. How long does this take you? Well, the scope is smaller, your error is smaller, but it's still not something that you've done before. So it could be between 1 day and 10 days, so 10x difference in estimation. What if now you are doing something, so you know Java, you know Spring Boot, you need to implement a new feature, which is a web feature in your web application. And the technology is not new, but what's new is what you are asked to do. Maybe it's not an area of the code where you worked. Maybe it's a type of work that requires more UI or less UI, or more database work and so on. How long does it take you? Most likely you'll have an error which is not as big as before, but you still might have a, I don't know, 5x error in estimation here. So this is a challenge, right? Because when you've never done this before, that's as much as we can say. There's an essential problem here, and there are ways to deal with that, which is to split a small experiment and say what would be the quintessential feature that, if I would do that first, to remove the risk for everything else. And you cannot give an accurate estimation when starting, but at least what you can do is to say, okay, let's do a spike, let's implement this one thing, and I'm gonna see how to make this one thing. And if this takes me 2 hours or 4 hours, or then I will know how long the rest of it takes me, because the rest is quite clear. I've done that before. I know how to do it. But this part, this core thing, I have no idea how to do it. So let's figure that out, and then might give me a 5x difference in estimation. But if we figure that out first, in 4 hours, 1 day, 2 days, one sprint, then things will become more predictable next. So then the question is, how much do you want predictability and how much do you want features? Right? Because the other approach to this would be to just say, okay, this is an important feature, we need to do it, let's start doing it, and then we'll monitor it and we'll see if we don't move fast enough and what blocks we are hitting. Okay, so the other essential challenge for accuracy in estimation is the process. No matter what process you're using, there will be something in the process that creates variation in estimation. Maybe because you need to wait for somebody, maybe because you have certain meetings, and so on. And it doesn't matter if it's Scrum, if it's Kanban, if it's team programming, if it's a combination of these or something completely different. You will have these things, because it's impossible to have complete and how to say, zero waste flow in your process. So these are essential, which means these are not as easy to deal with. And because of this, we are more interested in the accidental ones, because those are the ones that we can tackle first. First accidental one, you have, maybe this could be more, maybe some people will call it essential, I don't know. It's there's a natural human variation. I mean, one day you are very productive, the next day not so much. But the way we deal with this in agile teams, and this is why I moved it into the accidental category, is through collaboration. One thing that's very useful is if you don't feel 100% in one day, but you have a task, of course, to say, okay, my energy levels are not that great, I could use some help with this task. And then you collaborate in order to get you over the hurdle, and maybe after that you can move faster. So these are, it's an accidental thing which you can sort out through teamwork. That's very important. You need to feel comfortable to go to a daily meeting and say these things, and know that the team will jump to help you. Um, and these are all things that are important in a team. Then you might have other accidental variation sources external to the team. Maybe the CEO is coming and asks you to a meeting with everybody. That is important for the organization, presumably, but it will delay your work by half an hour or however it takes. If you get some bad news, if a lot of things can happen around your maybe team members are invited to specific meetings that they need to attend, and so on and so forth. So there are many things here and we can deal with some of these through certain constraints that we set in the team and somebody that defends those constraints. So for example, we might say we as a team decide to accept external meetings, but only between 2 p.m. and 5 p.m. because otherwise it destroys our focus. No, so you could do things like that, but you need to have the team to be on board with this, the managers to be convinced, and everybody, so that this is a constraint that you actually use and enforce most of the times. I mean, if the CEO comes and asks for everybody to attend the meeting, of course you go, but even if you have those constraints. And then there are some accidental issues with the process as well. The process might create these variations. For example, if you need to wait for somebody to do a code review, if you need to wait for someone to accept your pull requests, whatever process you have, these waiting times are accidental variations for your estimate. So one thing you can do here is to look at the cycle time and reduce the cycle time as much as possible by removing guardrails, but also while keeping the quality high. And that's the next point, because the other two elements that contribute to variability in estimations are existing design and bugs. So for existing design, this translates into technical debt. You believe that it's quite easy to solve a specific problem, but it turns out it's not. You need to change in 10 places instead of a single one because you have duplication in the code. So technical debt is a very complex topic, but in general, what you need to do is you need to prioritize as well reducing technical debt. And this translates, I've been a big fan of using this, and then Google said they are using it as well. But generally speaking, the best way to do this is to ask developers what are the parts of the code that you are afraid to change, what are the parts of the code that you feel create the most headaches, and then sit on a design meeting, the developers and perhaps somebody who can advise them, sit into a design meeting where they figure out how this should be, so that when new features come that are similar to the ones from the past, we can actually solve these issues faster and not have to change in 10 places, change in one place, and then have no or lower variability. And the second one is bugs. Bugs are a big disruptor. And of course, we cannot avoid all the bugs, but you can remove about 90% of the bugs through a few simple measures. Um, and the methods to deal with that are first, do root cause analysis for the bugs. This means for every bug you need to ask, why did this happen? 5 times. Well, until you get to a root cause, and then fix the root cause. And one of the nice things about bugs is that they tend to cluster, so they tend to come from a single source, which means if you do this, let's say every 2 sprints or every 3 sprints, do a root cause analysis for the bugs from the past 3 sprints and fix that cause, it's likely that you'll reduce those types of bugs by a lot. And the next one is having some preventive measures, because this is what happens before, but preventive measures include a good test suite, automated test suite that can catch bugs, that's designed to do that, and that developers actually use and maintain and trust. And then collaboration, pair programming, working with testers. Not only pair programming, but you can pair a developer with a tester, developer with a security person, or a tester with a security person, so that you find these bugs early and you fix them before they happen. And this takes us to the next thing, which is one that can help you a lot. Create checklists that you look at and that you follow in order to prevent these bugs. Checklists are a way of maintaining this knowledge of preventive measures. It's saying, okay, so we got to this point where we had these bugs, but now we can actually, we know that if we do this, if we take care of these 10 things in this checklist, then this will help us avoid those types of bugs. And there are probably more causes for essential and accidental. I just gave you the most important ones, the ones that keep coming back up. And the best thing about all this is that these are things that you can apply quite quickly. Okay, a good test suite might take a while to get there, but there are enough resources to get started and to make it work. And I hope most teams now have test suites. The big problem is to make them good, right? But root cause analysis is really easy to start with. You still need to face some truth. You need to remember one thing: you are never criticizing the person who wrote the code, but you're criticizing code, design, because everybody is under specific constraints and they did their best with what they knew at that point in time. But now we are at the point where you want to do better, and that's the general attitude. So it's never about blaming the people who did the things in the first place, but it's about the future. It's about preventing for the future and doing things better. And also know that many of these things will be contextual to your team. The checklist will be contextual to your team, because we all make, it's one of the beauties of people, right? That we are all different, which means we all make different mistakes, which means that within your context, within your team, you'll tend to make certain mistakes rather than others. And you need to prevent those rather than the whole list of, infinite list of possible mistakes that we could make. So with this being said, there's a lot more that you can do and you can analyze for. There's also a movement for no estimates, which means that you remove estimates altogether because they don't bring any value. And rather than estimating, you get good at splitting, which is basically incremental thinking. So splitting a big problem into smaller problems until they intuitively get right about the same size, and then you can just count those, and you know you have your velocity and you have your estimates based on that. But that is, I feel it's a more advanced thing because first you need to remove variability from the system, and part of variability is definitely technical debt and bugs. You need to address those before we can think about moving to the next level. At least that's my opinion after seeing many teams in action. So, what do you think about this? Does this help? If you need more help, let us know. We'd be happy to. And let us know in the comments if you have any other questions, any ideas, any situations you've seen, and maybe you would like to learn how to solve them. We love comments, we love answering, so let us know. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.